Hello and welcome to the video on AC, series and parallel circuits. Just a few things to note before I show you an example. First of all, in AC we talk about resistance as impedance. This is just resistance which is dependent on frequency, and it can be represented by vectors both in rectangular and polar form, with most calculators able to convert between the two quite easily. The key to solving AC, series and parallel circuits is the use of block impedances. Looking at my example here, this is where we redraw a otherwise complicated circuit into block impedances, allowing us to use the same techniques as we would with a DC circuit to solve. Okay, so here we have a simple parallel circuit with an inductor, capacitor and a resistor. First of all, to break the circuit up into block impedances and simplify the circuit, we want to calculate Z1 and Z2, with Z1 the impedance along this branch and Z2 the impedance along this branch. So Z1 is simply the resistor plus the inductor. Therefore, this in polar form is equal to 5 with an angle of 53.1 degrees. Next, Z2 is equal to just the capacitor, and this is equal to 8 with an angle of negative 90 degrees. So using our results for Z1 and Z2, we can redraw the circuit and simplify it. Now we can use regular current dividing rule to find the value for I1. So that is the opposite impedance over the sum of the two impedances times by IS. Now you do Z1 plus Z2 over here. You get 5 with an angle of negative 53.13. Put it back in the equation and you get I1 is equal to 79.43 minus J 9.57 in rectangular form. I2 is solved exactly the same way. Now we use Z1, so the opposite, over Z1 plus Z2 times by IS. So solving the exact same way, you get negative 36 plus J 34.6 in rectangular form. Okay, finally, for the last part of the question, we have KCL, which states current in is equal to current out. So showing our original model, we have the current in, which is IS, should be equal to I1 plus I2. Therefore, 50 angle 30 is equal to 79.43 minus J 9.57 minus 36 plus J 34.6. So adding like terms and converting to polar form, we get 50 at an angle of 30 degrees. Therefore, they're equal and KCL is upheld. In summary, all we've done is broken the circuit up into its impedances, simplified the circuit, solved for I1 and I2.